Hi guys, different classes are at different places with the black box, and so I'm making this tutorial so that I have the option of doing a live lesson about this, or you can also watch it here. What I want to talk about now that we've all done the black box lab and turned in our black box lab sheets is how do we judge the quality of somebody's model explaining how the box works. We can't open it, so we can't just say, well, this person's right and this person's wrong. And scientists have that problem too. When they investigate a black box, there's no authority figure we can ask and say, hey, are we right? So we have to be able to judge our own models and theories. And the way that we do that in science is there are certain rules that we look to try and make that decision. First of all, I want to introduce one of our vocabulary words, which is the word valid. Instead of saying judge the quality, I'm going to say judge the validity. And validity, let's see if I can get a pen that I can write that with that's reasonably small. Validity is one of your vocabulary words. There we go, validity. And it refers to how trustworthy and well done something is. And in science, we're constantly asking ourselves, are my ideas valid? Do they make sense given the evidence? Science is an evidence-based process, right? So if you're judging the validity of, let's say, this picture, is this picture a valid interpretation of the box? I would ask myself these three questions. First, does it explain all of the observations that we made? Second, could I make predictions about future observations and then test out and see if they come true? Do my predictions come true? And then lastly, did I apply Occam's razor? Have I made any assumptions that are unnecessary that I could shave away? So when you look at the box, any model of the box, there are a list of things you have to go through mentally in order to decide whether or not it works. Let's start with explaining all the observations. Let's look at a different picture to do this. Take a look at this model and ask yourself, do each of these observations that the students made, are each of them explained? So you see that the first observation here on this sheet of paper, I have paper copies of this if you'd like one, says when the funnel pointer is in the right-hand position, the clear water comes out the bottom tube as red. Now, right and left are reversed because you're looking at this picture backwards to how the student would have been looking at it, right? So don't worry about that. Look at the picture and ask yourself, is that what would happen if I poured water into the funnel at the top? Would I get red water out of the bottom when the funnel is pointing towards that side where the red is? To me, the answer is no, because the funnel has no way to direct water. That funnel, no matter which way this particular pointer is facing, no matter which way it's facing, it's going to always put water down the middle. They need to add a piece to this that makes the water go the right direction depending where that pointer is. And that piece, a lot of you solve that problem by making sort of a little J hook that comes out like this, so that that hook at the bottom of the funnel turns when the funnel turns and points the water in a different direction. So I would say that this observation is not fully explained by the model. And I could do that with each one of these. I could look at it and say, okay, when the funnel pointer is in the left-hand position, would I get greenish blue water? Well, same problem, right? When the funnel's in the center position, nothing's coming out. That makes sense. That's explained by this picture, right? There's a container in the middle that holds extra water. And as you go down, if the model is a valid one, you should be able to see that each observation is fully explained. Then, the next piece in evaluating a model would be to ask, can I make any predictions and then test them out? In this picture, I could ask these questions. If this model's correct, then when I do this, this will happen. Well, looking at this model, it seems to me that if this model is correct, when I pour water down the red side that was already colored purple by having gone through the right side, because there's a mixing going on, I should get a combination of colors between the two, right? So when the red and blue mix, if I pour blue colored liquid down the red side, shouldn't it come out purple at the bottom if this box is true? That's a prediction I could make. So I would write in here, pour blue water down the red side, and over here I would write, the water should come out purple. The last thing you would do is you would evaluate the model using Occam's razor. Are there any assumptions that you need to get rid of? I want you to try this out. Use the sheets that I've given you to evaluate this model. First, fill out the sheet, and then write a paragraph evaluating how valid you find it is. Use the information you put on the sheets as the details to fill in and support your argument. See you in class.